Hello everyone, this is Ashfaq Ahmed and I am PhD and postdoc in the field of structural biology and bioinformatics. Today we are going to perform a practical demonstration that how we can construct a phylogenetic tree. Before this part, we have already covered part 1 and part 2 where you can find the general introduction of phylogenetic tree and their namings, their branching, topology, etc. etc. In part 2, we have covered the different algorithms, like which algorithms you have to consider for your data, what are those algorithms which are accurate and which are computationally expensive or least expensive. So for those information you are suggested to watch part 1 and part 2. In today's video we are going to start that how you will be able to construct a phylogenetic tree for your data. So let's move. In today's video, we will cover 4 aspects. First, how will you generate a data? Like this, the first one is data generation. In data generation, it could be either nucleotide data or we will say genes or DNA data, or it could be an amino acid sequence, or we simply call them protein sequences. In step 2, once your data is generated, then we have some smaller step for removal of redundancy and renaming. This section will be already covered with the data generation step. In step 3, I will teach you how to construct your tree using BioEdit and Mega software. I will teach you on both these software, BioEdit and Mega. And finally, I will also teach you how to generate your tree by phonetic and cladistic approaches, which we have discussed in part 2. Okay, so let's move. The first step is data generation. So how we will generate a data? Consider you have a sequence. I would say you have a sequence of protein sequence. So you can take your sequence from anywhere. Here I am going to take that sequence from this database. This is a protein sequence database. We call it UniProt. Okay, let's say I name it to some protein. I would say EGFR. That's it. Okay, so you have just to enter the name here in the UniProt. Remember, if your data is a protein sequence, you can take your sequence information from UniProt. Otherwise, if you are dealing with genes or DNA sequences, then in that case you have to take your data from GenBank, EMBL or DDBJ or some any other website. Okay, so you have to search here. Also, let me inform all those people who are dealing with their sequenced gene. Some people they are sequencing their genes and they have the sequence information. Then for them there is no need to take data from UniProt or DDBJ or another database. Simply they will follow me from the next step. So here we are selecting our gene or sequence, and in their case they have already their sequence. So for example, this is all the EGFR data located on this database UniProt. So it's from mouse and it's from apis and it's from macaca mulata, and this is from Gallus, we also call it chicken. So this is a session number, this is the entry name, this is protein name, this will be the gene name, and this is an organism name. So you should know where your sequence is located. Let's say my sequence is from chicken, Gallus Gallus. So I will open this. Once you open your desired location, then click here on the left side, click this sequence. So once you click this sequence, you will have this kind of sequence. You can see. Okay, now what is next? You can see here copy sequence. Just click copy. Okay, once you click copy, okay, here the game is over. Now we will move to another software or another web page. We call it NCBI. If you cannot see this, so that's okay. You can come here or you can go there through Google search. Just write NCBI. NCBI. It stands for National Center for Biotechnology Information. Okay, here you have to click BLAST. Here it is. It stands for Basic Local Alignment Search Tool. So once your BLAST page is open, it will look like this. Okay, now you can see two main windows, one on the left side, one on the right side. Ignore these two. These are some, they are related with some translated BLAST. So I hope at this point you will not you will not need the translated BLAST. So if your sequence is a gene sequence or a DNA sequence, then you have to click nucleotide BLAST, but in our case our sequence is a protein sequence here, so we will click the protein BLAST. The sequence we already copied here. Copy sequence again. No, and just paste your sequence here. Now the sequence is pasted. Use your mouse, and I suppose you are dealing this website for the first time, so to be a bit quicker I am choosing the quick blast. Ignore all these steps, but if you want to generate your data from some specific website like say Uniprot, then select a Uniprot here. Otherwise leave it is. So click the blast button, locate it here, and we will wait for some time. So I'm going to pause this video because it may take a minute or two. Okay, welcome back. So we have our data, and it took almost 2 minutes. Depends on your sequence size and depends on your internet connection. So now you have this this web page, and all these are the blast information for your sequence Gallus Gallus. This is your sequence, epidermal growth factor or EGFR of chicken. So how you will gather your data set, this is very important. So be concentrated. Okay, select all. You have to uncheck this. So all the sequences are now unchecked. Okay, now we have to select our sequence which we want to be included in our data set. So here if you can see Gallus Gallus and Gallus Gallus, both these sequences, one is the isoform and one is the normal sequence, both of them are in the data. So for most of the time I recommend people do not select the isoform until and unless your study is specifically designed to check the comparison between isoform. If it is not so, then do not select the isoform. Just select one sequence per organism. I mean select one sequence from one organism. So here I will select, this is my sequence Gallus Gallus. Now you can see once again this is from this organism. We have two sequences, one is isoform 1, one is isoform 2. So I will select 1, and once again Gallus Gallus, so ignore it. Now select this one, select 1, this from these two, select this one, select from these two, select 1. Okay, select this one, select this, So I'm going to randomly select few more. Okay, so why I ask you not to select a duplicate data? Because if you have selected these two, so in advance I'm telling you that both these two sequences will lie on the same node. And then if someone asks you in the interview or in your defense exam that your sequence EGFR from Gales, what was its neighbor homologue? And your answer will be from the tree, and that will be again Gales. So technically it may sound not good that my Gales, the protein sequence I have, is the nearest homologue of the same protein sequence from Gales. So it may create confusion in the reviewers or the examiner mind. So that's why do not select a repetitive data or redundant data. Okay, so we have already selected 12 sequences. I think that will be enough to show you how to construct a tree. You can see here 12 sequences. Now what is next? You can see here the download button. Click this icon, the downside arrow, and download the complete FASTA sequence. Do not download the aligned sequence. I want you that you align it by yourself later on. So you have to download the FASTA complete sequence. It will be downloaded here. Now it should be here. So I'm copying it. In fact, I have cut it and I will place it in a folder located on the desktop. Its name is tree folder. So I will keep it here, paste, and I will give it a name, let's say EGFR. Okay, let's open the file, how it looks like. So the file looks like the first line will be the name, and then from the second line you will see the sequence. Okay, and the name will contain the accession number, the name of the protein, a longer one, and the name of an organism. And each sequence will be started from this kind of sign. You can see here the greater than sign. We call it in bioinformatics header. So each sequence will be started from header, and you can see here this is another sequence, this is another sequence. So one thing, uh, the part 2 is, if you see here, it's renaming. Okay, so we have already removed the redundant sequences during preparation of this file. Now we have to rename. Why we rename? Because if you see, these names are so bigger, so longer, so it will not looks like great in a tree. So I would suggest to you rename it this way, like I deleted EGFR dash Gales. Okay, remember, do not remove this sign, the header sign. So once again I deleted this and I name it EGFR. So I have just edited two names for you. You have to take your time and edit all these names. So it will looks like beautiful, and it will look like it will looks meaningful in a tree. EGFR of this. You can also further work with this, like L this, or you can say like this, G Gales. Okay, so now save it. I have just edited two names. You have to edit all your name. Okay, and I click it save, so the file is saved. Okay, we have completed two steps. We have generated some data for our sequence, and we have also performed these two steps. We did renaming, and we also removed the redundancy data. Now we are coming to part 3, how to construct or phylogenetic tree using BioEdit and Mega. So first of all, I will work on Mega. It's a bit simpler, so also I will work on Mega. If you do not have Mega in your computer, I have this Mega 11. So that is simple. You just write Mega download, and you must have a 90 MB file. You can see Mega desktop app. You click here, and somewhere on the website of Mega you will see this. So you have to download your Mega software and then install it. Okay, and the same way you can download BioEdit. I just write BioEdit download, and you will see here a 12 MB file, this one. So it is up to you to use Mega or to use BioEdit. The BioEdit program is very simpler and very smaller, 12.4 MB, and the Mega program is a bit more professional than BioEdit, and it's a bit heavier too, that is 90 MB, but it will not be a problem for your computer. So let's move. You can download it, you can install. So I suppose you have now some program installed. So let's open the Mega file. I have already this Mega, so it will look like this when you open it. So before uploading your data to the Mega, you have to perform some step. What step? Okay, this is our file. So what you need to do, you just open it and you just click save as, not save. So I'm going to save it again, and with some changes. The file name is EGFR. You can name it like EGFR1. Okay, and here save as type, in this section you have to select all files. Now EGFR1 dot fst. Okay, so save it. Okay, so you have now two files. You have a new, this is the older EGFR and this is the EGFR1 we have created just now. You have this Mega. Now the first step we need to is to align our data. Okay, because the data is not aligned. So click here, and now edit or build alignment, this section, the first one. Click here. In our case, we are creating a new alignment. Yes, so select this section, create a new alignment, and okay. Now the program is asking us that are you dealing with DNA or protein. So in our case, this time we are dealing with protein. So click protein, and let's say open. Wait, I made some mistake. The first step, we have first to load our data through file, open file, then EGFR, align. Okay, it looks like this. It's very easy. Okay, see again. Once your program is open, file, open a file session, and EGFR1, align. Okay, this is our align file. If you want to do align again, no need to align again, or otherwise you can also do it align aligned by cluster W or muscle, but for protein sequences I always suggest to align by muscle. So you can also do align again, that's not an issue, it will take some time. Okay, so this is the alignment. You can save it if you want from here, otherwise you can save your session if you want and save like this. Okay, so now how will you generate a tree from this data? So close it. Now this is the main window. Now we are this is the tree section, you can read it, phylogeny. Okay, click here, and which tree you want to construct. We talked about in part 2 about the different algorithms, so you have to consider which tree you want to construct. Either you want to go with cladistic method or phynetic method. One of them is a distance based method like UPGMA, and another one is parsimony method, where least mutations or least number of mutations are considered. So let's say I'm going with maximum likelihood. Okay, so they will ask me some, wait, phylogeny, construct a maximum. They are asking me for a file, so I just select all files here so that I can see my file, and I can select EGFR1 alignment. Okay, and it will come like this. Now you can see statistical method or a statistical algorithm is maximum likelihood. Okay, I think do not interrupt the other steps, otherwise you can maximize your analysis. It will take more time. Let's say if you change these number of threads to more threads, if you have system resources like you have Core i7, you can increase it to 6 or 7. Otherwise, in case of Core i3, the 3 is by default. Keep it here. Okay, which model or what other things you want to know, these all are mentioned here. So in some other video I will cover on these models and these evolutionary sites. So now here we have to just click OK. So once you click it, you can see this kind of tree. Okay, you can play with your tree, like you can play with the layout section, you can play with the taxon. These are the taxon, the font you want to increase or decrease, you can see, and you can play with this section. This is the layout, which style you want this style, or you want some another style, this one, or you want some circular style, this one. Okay, or you want some traditional curved side, or you want, so simply I mean you can play with this, and you can increase or decrease the tree width from here, you can see. And this is technically unrooted tree. You see there is no specified root, just an unrooted tree. Okay, if you want to make it a rooted tree, then you should have the information that which sequence should be considered as a root, and for that you have to click here, not here, we will click it in some other section. Okay, these are information about the branch length and its sizes, you can tweak here, and placement is automatic, or you want it below or above the branches, that is up to you. So I'm not going to waste much more time here. The captions, each and everything, you people all know what it means, and Okay, you can export this tree in NIVIC format or in some text file from here. Okay, so now how to save this tree? Wait, you click here, image, in which format you want to need it. Save it as PNG, BMP, PDF, TIFF, EMF or SVG. So once again, okay, one thing more. You can see the names on the tree. These are very longer, but those two names were we edited, like the EGFR from this and the EGFR from Gallus. You see they are very beautifully crafted here, and they are shorter, so that's why and it makes sense that this is EGFR of Gallus, this is EGFR of Lucra. So, but these longer names, they are not making some sense. You have to read all this. So that's why I'm with a view that you must rename all your sequences before going to draw it. Okay, so you can see your save your image from here directly. Now if you want to compute a time tree or compute an ancestor, so for time tree you have to select a branch, from which branch you want to or from which taxa you want to calculate it. What is a time tree? I have also talked about the molecular clock in my first video, so you can take help from there and compute a time tree. Okay, so this was all about mega, how to construct your tree. Now we are going to okay, cancel, discard results. Now I'm going to teach you something for BioEdit. I suppose you have BioEdit program in your system. If you have downloaded, I teach you already how to download the BioEdit system. So click File, Open. We have the data here, EGFR. The first step is the alignment section. Come here, the accessory application. How to let me show you again. Once the BioEdit program is open, click File. Now open. Now select EGFR. You will have your sequences. You can see two sequences. The names of the two sequences are here, which we have edited, and these are the other names. Okay, so now you have to come here, the accessory application, and click this cluster, multiple cluster W, multiple alignment, and run cluster W here. Okay, it may take some time based on your data or based on your sequence information, how longer or how smaller they are. You can see on the screen. Okay, now this is the calculated alignment. If you want to analyze the alignment, you can change the colors from here. You can see I'm just clicking. So that is up to you which layout you are going to like it. Okay, now once again click the accessory application. For DNA, these are the DNA stuffs, and these are the protein stuffs from it. So if you are dealing with protein, so you have to deal with these options. If you are dealing with gene or DNA, so you have to deal with these options. Okay, first I'm going to draw a protein distance method. So that is neighbor joining, neighbor phylogenetic tree. Click here, run application, and they are asking for an output file. So simply you can write something nj, okay, and save it. It will take some okay. So it will take some time, you see, and it has created so many windows. So the first window you are seeing, they are telling you like which model did you use. So you have used Neighbor-Joining or UPGMA version, this one. Why these information are important? Because when you will write your report or your thesis or your paper, so you have to write all these things in methodology that I have used Neighbor-Joining method, and the tree, and I have used any triplet dataset. No, we did not use any triplet dataset or write a tree in output file. Yes, or did you select any outroot or any outgroup? So no, we did not select. We just asked the program to draw it, and this is the tree, and how many cycles were performed. So you can count these cycles, and what was the node statistics on node 1 this, node 2 this, node 3 this, and this is done. Okay, I'm going to cancel this. Okay, no. Okay, this is actually the tree, but this is a NIVIC format tree. So I'm going to save it, and will tell you why I'm going to save it. Save as in text file. So you say EGFR and tree, EGFR dash tree. So I'm going to save it EGFR dash tree. Yes, okay, close it. This is your tree file, and generated by BioEdit. So you can save it, or you already have the text file which we have saved a little earlier. So that doesn't there is no problem if you are not going to save it directly from here. So you can cross it. Okay, these are the information. The tree generation are almost the same tree here in some text format. So you can cross it. You will not need this. Also cross it. Okay, so the same way you can also try the other methods. That's not a problem. But before to wind up this video, let me tell you why I have saved this file, EGFR tree file. You can open it in Notepad, this one. Okay, so I'm not sure that the video will be necessary or not, but you can keep this file, and you can upload this file to some online servers where you can generate a very beautiful tree. One of them I'm going to tell you like in which server you can take help. So the server name is iTool. Let me show you. iTool Intricate Tree of Life. So what you need to do, the file you have saved in NIVIC format, we call it NIVIC format, NEWICK. So you have to open this website itool.embl.de, and once this website is open, you can upload that file generated from Mega, or generated from BioEdit, or generated from some other program, and upload it here. When this website is open, you will see there will be an option for upload a tree. So you have to upload that tree, upload a tree here. So when you upload your tree here, let me upload one file for you. Upload a tree, and the tree is here. We have saved already, EGFR tree, and click upload. So once the tree is uploaded, you will have greater opportunity Because of this, you can see this is the tool panel. You have very good opportunity now to beautify your tree. Like I'm selecting the circular, it will be like this. I'm selecting the rectangular, I'm selected the unrooted thing, and I'm selected the tree inversion, tree not inverted. So you can make many changes here, and after that changes you can just export your tree in a very high resolution picture. Like I have exported here in SVG format, but you have export your tree in PNG format, I would say. And you can also adjust the resolution from here. This is 120 dpi, you can export into 600 dpi. It will be a very high resolution tree. Manage your colors, your analysis from these panels, and make your tree really a beautify and a beautiful one. And also consider these things. So at the end of the day, you will have a very great tree for your thesis and analysis. So that's it. That was for this video. I try my best to wind up this topic, phylogenetic analysis. If you like my demonstration, please support me and suggest me in the comment section if you are interested in some specific topic or in some specific tutorial. Otherwise, stay tuned, and I will bring much more exciting and shorter stuff, and which will be very helpful in your thesis and your daily life or research analysis. Thank you very much. All the best, good luck, and stay happy. Bye bye.